Today's presentation is about the positive aspects related to the developments within artificial intelligence and machine learning. Rather than considering them as something that could be risky or negative in the society and in the life of people, taking our jobs or otherwise endangering us, we can think about how to use these technologies, these methods, for the good of the people. So these technologies in the service of the good. And first of all, we can think about different uses of these technologies, depending on what kind of skills we can simulate with computers. We can consider, for example, the fact that many systems nowadays, they have perceptual skills. They can analyze images, videos, speech, sound. They can deal with linguistic input, written words, spoken words, sentences, larger collections of texts. Systems can process symbolic information as well as conduct intuitive reasoning, simulate unconscious mental processes. These systems can be used for problem solving and even for creativity. The systems can be used to simulate emotions, to understand human emotions and to model social activities. As well, these kind of methods give chance to analyze anticipation, to understand future scenarios and to have models that analyze time series. Why are we now in a new situation? Data, big data. We will have chance to deal with this kind of data-driven methods that model the world in an empirical manner. And to deal with this data, one is typically using machine learning methods, machine learning based artificial intelligence, where some kind of statistical methods are being used to create models of these large collections of data. This kind of approach is nowadays used widely by companies like Google, Facebook, Amazon, etc. It is good to remember, however, that the majority, I would claim, of these methods have been originally developed in universities and then later applied and further refined in products like IBM Watson or Google Translate. One can view AI paradigms divided into two categories, a rough division into data-driven approach versus theory-driven approach. From the point of view of classical philosophies, reasoning can be deductive or inductive. Reasoning can be viewed to be logical in the traditional artificial intelligence, but on the other hand, it's commonplace nowadays to consider reasoning from the point of view of statistical, probabilistic or neural processing. Models can be explicit, kind of reflecting rational, some kind of or so-called rational thinking, but on the other hand, the models can be modeling intuitive processes, intuitive thinking, unconscious processes of this kind of which are or have been becoming more and more interesting among researchers. At the level of representations, the representations can be symbolic, but they can be pattern-like or vectorial. And the same kind of distinction is related to using ontologies versus word or document vector spaces. In practical terms, this is a rough division into two, but practical systems are often built using combination of various kinds of techniques based on both sides of these kind of assumptions. If we take some examples, for example, regarding pattern recognition, speech recognition is a good prototypical example of pattern recognition where the high-dimensional signals in time are processed to reach interpretations at symbolic level as words in written language. One of today's presenters, Professor Mikko Kurimo, has been working in this area successfully for a long period of time. Written language can be analyzed in a handwritten form, like another speaker, Dr. Jorma Laaksonen, will be discussing these kind of developments in detail. Regarding also pattern recognition of images and videos and how to process them for automatic processes that can help us in various ways, as we can see in other presentations. In addition to analysis, we can have pattern generation, like in the recent experiments conducted by Google researchers in order to generate kind of combination of visual concepts and to have interesting patterns based on this kind of approach. In addition to this kind of pattern-like data, we can deal with large collections of textual data, and it's obvious that text corpora are an important source for machine learning systems too. And for example, in Finland, the primary example is the Finclarin corpus, which contains many kinds of contents that can be used in various ways in developing systems and in research in different disciplines. I'm happy about the traditional results from year 1995, when we had a corpus of Grimm fairy tales, and in a result that is preceding the currently very popular topic modeling, we were able to conduct data-driven analysis of the text collection, and in such a way that gave rise to emergent categories like nouns and verbs, and within nouns, for example, inanimate and animate nouns emerged automatically based on the use of machine learning algorithm, self-organizing map, and contextual information without any linguistic input. And it's not always sufficient to deal with linguistic input, but in order to simulate how humans learn language, language is learned in multimodal context, and we had an Academy of Finland project on multimodally grounded language technology, where one result was that the human movement was modeled in detail using these kind of pattern recognition techniques, where the human movement was measured very much in detail. So the motion tracking devices were in use, and the kind of patterns in space and time then were associated with their linguistic descriptions. In this way, the machine was able to kind of understand how the words relate to the counterparts in the reality. This approach can be seen as a kind of relates also to the idea that robots would learn to use language, and of course there are projects on this matter too in the world. In another theme related to language is that of sentiment analysis. So traditionally the focus has been in trying to understand how computers could make sense out of the contents regarding semantics of the texts, but from the practical point of view as well as from the theoretical point of view, it's actually very interesting also to know how human emotions are reflected in the texts. This is quite interesting for companies that want to learn to know how their customers relate to their products or their services, but there are many kinds of societal possibilities related to the sentiment analysis of texts. Another important field related to language technology is multilinguality and machine translation. So here I have picked up one example from our new professor Jörg Tiedemann, who has conducted research in this area for a long time, and the idea is that one can build statistical machine translation systems like Google Translate that build bridges over linguistic borders. The second part of my talk today focuses on the positive aspects of artificial intelligence and machine learning developments and their use for various purposes. So we can consider some life-saving applications. I start with a potentially controversial issue, namely that of robotic cars. Robotic cars have been used and developed to some extent, but they are still at the stages of early or intermediate developments. But here the scenario is actually that we can save something like 1 million lives per year with the use of robotic cars. Namely, in the world, more than 1 million people die every year in traffic accidents. And my conviction is that robots, or let's say computers, will be even much better at some stage in driving cars than we human beings are for the moment. Often we do it well, but human beings can be tired, have different health conditions, they may be angry, they may be in an optimal situation in various ways. This will be of course true for robotic cars too, but the claim is that the ratio will be beneficial for the situation when artificial systems drive these technological dangerous systems and leads into a better situation than before. It's quite obvious that artificial intelligence and machine learning can and will be used in the area of healthcare and medicine, and one of our speakers, Dr. Jaakko Holmeen, today will discuss this in detail. Here is one example of one recent publication related to cancer research. But the basic idea is that there will be all the time new opportunities to conduct medical diagnosis and treatments based on the new technologies. Already now they can be used in very basic diagnostic work, but the further the developments go, the closer we are in the situation that it's beneficial actually to rely really on the computational systems rather than human beings. But there is, in the future too, there is of course an interface, but the roles regarding the analytic work will be developing in an interesting way. This title of thinking about going towards peace and prosperity contains, let's say, big words, but there are various views or ways to see that why artificial intelligence and machine learning could also promote these kind of ideas and developments. The fact that we speak many different languages causes troubles in the world. And even if it's not so that the peace would follow if we have really good machine translation systems, at least we can avoid some problems. And it also promotes prosperity, that we can conduct business negotiations and discussions over borders, for example in Europe, in comparison with countries which have much smaller number of languages in use. Our own work related to understanding misconceptions, different conceptual systems, and the kind of fact that we have always the danger that we understand concepts, words differently in a population, leading to a situation where the heads of the countries, or doctors versus patients, or parents versus children, understand central or key expressions in a different way. And that's why we have been developing methodology called grounded intersubjective concept analysis, with a certain kind of promise towards developing translation within language, so that the system would actually serve as an interpreter among us in difficult or problematic communication situations. We can put text mining into use to understand historical developments in the world. So, for example, when we have the historical newspaper collection at the National Library of Finland, So when this kind of collection is in digital form and available for the researchers, we can make systems in collaboration with history researchers, sociologists, to increase our understanding of developments that led, for example, in the wars, First or Second World War, etc., etc. We can also create understanding on how social systems work using these kind of methods in relation with social media collections. So, for example, Krista Lagus will refer to the collection called Suomi 24, a large social media text collection that tells about social life in Finland and how people agree or disagree and discuss about various topics. And the millions and millions of items give a view on how matters are being dealt with in the social world. In general, we can gain increasing understanding of the complex socio-economical systems. We can use these kind of data sets that were mentioned and combine them with crowdsourcing efforts, data analysis based on statistical machine learning methods, and also simulation to simulate complex phenomena to increase our understanding, and in this way to improve the chance for good decision making. It's also good and important to develop and use these kind of methodologies to develop what can be called information society for all. And these developments are being discussed in Professors Liisa Tiittula and Mikko Kurimo, who discuss this topic from one point of view related especially to speech, and in Liisa Tiittula's case also providing view on the practical needs in this area. And then Jorma Laaksonen will be discussing this from the point of view of analyzing video contents and visual contents that then can be analyzed in a way that the provision of the contents for wider audiences becomes possible. As a conclusion, so many positive developments are already taking place and will be possible. And of course, negative effects and scenarios have to be taken into account. But it's actually good to focus on the positive side, to have a mindset towards these positive developments. Interdisciplinary theoretical and practical work is needed related to philosophical questions, ethical concerns, and this can be related to privacy issues, to take into account the social aspects and implications of artificial intelligence. For example, it's a fact that machines are taking many jobs, and how to organize things in a good way. So the economical system will be revolutionized even in some sense, and we have to be sure that the good political decisions are being made to deal with this, not to just to say that everyone has to find a job when the we have an unforeseen situation regarding the effect of technology on the human condition. But in general, I'm very optimistic that the world can be made to be a better place by applying and wise use of artificial and machine learning. We just need to be careful and wise in applying these methods. Machines are not human beings, and that's why we have a full freedom in how we deal with them and how we use them for the benefit of all. As a final remark, I would like to remind you of something that I heard quite recently from Professor Bengt Holmström, who reminded that at MIT students for them it's obligatory to study humanities and social sciences. And therefore that gives us a view on the idea that we can, and it's beneficial to keep in mind the two cultures in parallel, so that humanities and social sciences join forces with areas like artificial intelligence and machine learning in order to build a better future. For example, through the work that is being conducted within digital humanities. At some stage, I would say that one can also consider the fact that we are conceptually dealing with computational humanities, not only digital humanities, which underlines the kind of having the data in digital form, maybe processing it, but the processes related to these materials can be better described with the term computational. Thank you very much for your attention.